have today an exercise for excellent people. This exercise belongs to previous 3 second term geometry branch. It's for lesson number 5. The title of our lesson is the relation between the chords of a circle and its center. The relation between the chords of a circle and its center. Our exercise is M and N are two circles of radii length 4 cm and 5 cm. M and N are two circles. M and N are two circles of radii length 4 cm and 5 cm. So N have radius 5 cm radius length and M have 4 cm radius length. The line segment AC touches the circle M at A, and cuts the circle N at B and C. Cuts the circle N at B and C, where BC equals 6 cm. The chord BC equals 6 cm and MN equal 12 cm. The line segment MN equal 12 cm. So since the distance between the two centers of two circles are is 12 cm. What is the requires? First requires prove that the quadrilateral MACN is a trapezium. Then calculate its area. So at first I will prove that the quadrilateral MACN is a trapezium. Then after that I will calculate its area, the area of that figure. The second requires FCD equals CB. FCD equal CB. Find the distance between N and CD. Find the distance between N and CD. Solution. At the beginning I will make a construction. Construction is drawing an bisector passing through N and divide the line segment or the chord BC into two equal small line segment. So I'll draw such projection from N passing through the chord BC. It will bisect it into two small parts, and I will denote it just the intersection point. I will denote it by E. From the previous lessons we studied that if I have a line segment passing through the center and bisect the chord, it will be perpendicular to that chord. So the angle NEC will be 90. It will be a right angle, and we can to make it easy to us, I will take that figure MNCA outside this figure and I'll draw it outside. So that is the point E, the point of intersection. We can note either that since EC equal 6 cm, then the half of 6 cm is 3 cm. So the length from this point to this point, from E to C is 3 cm. By applying Pythagoras theorem, I can find this length, the length of NE. So NE squared equal NC squared minus CE squared. NC squared equal 5 squared minus CE squared equals 3 squared, so equal 16 centimeter. So NE squared equals 16 centimeter. Then NE, the root of NE, or the root of 16 equal 4, so the length of NE equal 4 centimeter. So the length of NE equal 4. I'll go back to that figure to find this angle. You can note that the line segment MA passing through M and A, and CA is a tangent and M is a center, and there was a corollary says that if we have a line passing through the center and touches the tangent passing through the center and touching the tangent at the point of tangency, then the point of tangency, or the angle between the radius and the tangents, will be right angle. So that angle MAV will be a right angle. So that angle is equal 90, right angle. So this angle is right, so this angle is right too. So since the angle MAE is right angle and the angle NEC is right angle too, so the line MA parallel to the line NE. Since MA parallel to NE and MA equal NE, then the angle A and the angle A equal 90, then the angle MAEN is a rectangle. Since MAEN is a rectangle, then the line MN parallel to the line EA, the line MN parallel to the line EA, and that's one of rectangle properties. Then MN parallel to AE. And what's you can note here? You can note that C belong to the ray AE. C belong to the ray AE. Then MN parallel to AC. Since the figure NACE is a trapezium, and that will be the first part of first required. The second part is he demanded from me to calculate its area, the area of MNCA. How can I calculate this area? I can do that by dividing that figure into two figures. I will divide it into a rectangle MAEN and right triangle NCE. I will calculate the area of each one of them. The area of rectangle is 4 times 12. 4 times 12. And the area of the right angle, triangle is half time 3 times 4. The first one equal 48, the second one equal 6. So by adding that the area of rectangle plus the area of triangle to give me the area of all that shape. So the area of trapezium equal the area of rectangle plus the area triangle equal 48 plus 6 equal 54. 48 plus 6 equal 44. That was the first require. The second requires if CD equal CB, find the distance between N and CD. The distance between N and CD. What I can do here, I will draw that figure, a part of that main figure. The radius is NC equal 5. I will make construction. I will make a bisector. I will draw a bisector passing through N, from N passing through DC, and will bisect it to equal parts. That's what's that. And BC equal 6 is given, and DC equal CB, then BDC equal 6, and the half of 6 is 3. So that's line segment equals 3. That's what from here to here. I will draw it by let's say R. Okay, R. So R C equal 3 and NC equal 5. So if I want to get that length in R, I will apply Pythagoras theorem. NR squared equal NC squared minus RC squared. NC squared is 5 squared by substitution from its value. NC equal 5, so NC squared equal 5 squared minus by substitution by RC value. RC equals 3, so 3 squared. 5 squared minus 3 squared equal 16. So NR squared equals 16. By applying by adding a root over two sides, I'm performing this operation. So NR equal 4. Then the length from from N to R, or the length or the distance between N and CD is equal 4, and that's all the second require. And that's all for today. You can share and like and subscribe our channel to support us. or you can follow us. You can follow our page on Facebook, Mr. Mukhtar for Math, and goodbye.